So for two variables, we have seen that the contrast of A can be calculated as AB plus A minus B minus the control. Now to calculate the effect of A, we have found that formula is 1 by 2n AB plus A minus B minus the control. Now we also calculated the SS of A for two variables is 1 by 4n times the contrast whole square, so minus the control whole square, like that. Now if you want to calculate the estimate of the regression equation, which is the 1/2 of the effect, or you can write 1 by 4 of the contrast. Now this is fine as long as you only have two factors. So this will work fine if you have only two factors or two variables or two independent variables. It will not work if you have, say, more than two, 3 factors, 4 factors, 5 factors. It will never work that way. So the way we should write this, this equation, I modify this in a way 2 to the power k minus 1 times n, and everything else is same. So whatever that we find here is good. Here same thing, 1 by 2 to the power k n, and then whatever in here. For 2 factors we will only have this. For 3 we'll have some more stuff there. So to calculate the estimate, similar thing, 2 to the power k and then bunch of stuff there. One more thing, the total sum of square formula in the book for two variable is given in textbook is like this: summation of I 1 to 2, only 2 levels, summation of j 1 to 2, and then summation of k 1 to n number of replication, and then y I j k whole square minus y dot 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 whole square by 4n. Once again, it will work if it's only 2 variables. So this 4n will not really work if it's 3, 4 or 5 variables. So the way we should write this total sum of square is basically I1 equal to I j 1 to 2, and then k 1 to n y I j k whole square minus y square dot 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 divide by 2 to the power k n, not 4n. So this will work for any factor level. I would say 2 to the power k design, this will work, but this left side only work for 2 to k 2 power 2 design. It cannot be generalized. These formulas 4n cannot be generalized for more than 2 variables. You could generalize using this k, so now everything else will work fine. So on this Excel page we have solved a problem. Here you can see this has A, B, C, D, 4 factors of 4 variables, and then we have 2 replications, one replication here, one replication here, full complete 2 replications. So what I did to calculate contrast, I just simply multiply the A column times the response, and then I added all of these as we have seen in the earlier video how to calculate contrast. Check that one first. So you just add all of them to get the contrast. Now to get the effect, basically contrast, the way this 16 comes, remember the formula I wrote, 2 to the power k minus 1 times n. So we have 4 variable, k minus 1 is 3, so 2 to the power 3 is 8 times 2 is 16. It works here. Now to calculate the sum of square, basically contrast is square divided by 32. The way this 32 comes, 2 to the power k n, k was 4, so 2 power 4 is 16 times 2, that's 32. Now to calculate estimate, you could simply do 1/2 of the effect, or you could do the formula that I give you, the contrast divided by 2 to the power kn, which will be basically 32. And then you calculate all of this estimate sum of its square for each of these factor, and then we can create the sum of its square formula. Look at this. So what I did here, I create another column, this last column here, basically multiplying the response. So what I did, I just square this in the last column, and then I calculated the total of the square here. So you can see sum of all these. So the formula for total sum of a square is ijk square minus the total square. This is the total in this contrast column, divided by 32. The way that 32 comes is 2 to the power k times n. We have 4 variables, so k equals 4. 2 to the power k would be 16 times 2 is 32. That's how you get this contrast, this sum of a square. Now we can transfer all this to an ANOVA table. What I did is I just simply transpose all of this effect here, and then just basically copy from the previous page. This calculation comes from previous page. Now error, which we don't know, the way it can be calculated, the total sum of a square minus all the effect. So as you can see here, so total sum of a square minus all the sum of a square associated with the others. So total is in this B3 cell minus the total sum of the everything else. And then the degrees of freedom for A is 1, because you got 2 levels of A. 2 minus 1 is 1. Total data point is 32, so n minus 1 is the total degrees of freedom. And then all the degrees of freedom, other factors degrees of freedom, we can subtract that from this 31 to get the error degrees of freedom. Then the ms is basically average sum of its square, so sum of its square divided by degrees of freedom. And then f value is basically the ms of that divided by the error msc. And then p value can be calculated as fd is like that. So I hope that explains the theory on how to manually calculate the responses, and then effects, estimate, and sum of its squares. We can completely manually create ANOVA table, regression equation, things like that, using this manual calculation formula.